Hi guys, this is the next part of 3C where we're going to multiply radical expressions. On our first 3C video, we did example 2 and 3 on the first part of 3C, and that part we were combining like terms for radicals. Okay, on this part, we're going to multiply radical terms. And what we want to remember when we're multiplying radical terms is that we're going to remember that the outside numbers on radical terms will multiply outside numbers, inside numbers will multiply inside numbers. So let's go ahead and do example number 1 on multiplying radical terms, okay? On example number 1, we have 2 roots of 6 times 3 roots of 12. And when we're multiplying radicals, of course, we've got different rules than when we're combining terms or adding and subtracting. So we want to remember that we're going to multiply outside terms with outside terms and inside terms with inside terms. Okay, that's how we'll multiply radical terms. So when we do that, we're going to multiply 2 times 3, that'll give us 6, okay? And then when we multiply that root 6 with the root 12, we're going to get the square root of 72, okay? So this is how we're going to multiply radical terms. And that was example number 1. And we can't leave our answer like that because we always want to simplify our answers. Simplify our radical answers, our radical term answers. And that means we always are going to use our factor trees and see if we can simplify that radical, okay? And so this radical will simplify, and when we divide out and do our factor tree, we're gonna get a factor tree that looks like this. And since we have an index of 2, we're looking for matches of 2. And for every match of 2 that we see, those can bust out. Okay, so we'll have our 6. It's going to multiply a 2 and a 3. But we had a 2 that didn't have a partner and has to stay inside. For our answer, we're going to multiply those numbers on the outside again, and that'll give us 36 roots of 2. So our answer on example 1 is 36 root 2. All right? Let's go ahead and take a look at example number 2. So on example number 2, we've got one radical term on the outside of a set of parentheses, okay? This is example number 2 of multiplying our radical terms. And what our problem says is square root of 3 times minus 2 square roots of 6 plus square root of 15. And just like we did before, when we have one term on the outside, we can distribute, okay? So we can multiply that root 3 times both of those terms on the inside. We could also make a box, okay? So we can make a 1 by 2 box, and that would look like this. So our term on the outside would go here, and our terms here would go up top here, and we'll multiply those terms on the outside just like we did with polynomials. So that minus 2 on the outside is multiplying our invisible 1 on the outside of our root 3. So we'll get minus 2, those are those outside numbers multiplying, and then our inside numbers, 6 and 3, will multiply to root the square root of 18, right? So outside numbers will multiply outside numbers, inside numbers with inside numbers. Now we have a plus 1 on the outside of our root 15, multiplying a plus 1 here. So we've got an invisible 1. And we always want to bring down our sign here. So we've got a plus on the outside of that next term. And our 15 times our 3 will give us a root 45, okay? And we would have gotten the same two terms if we distributed. You can do it either way, but you need to bring those terms out of your box and simplify them, okay? I'm gonna go ahead and simplify them here, and that's fine too. And when we simplify those terms, right, what we're looking at is just doing those factor trees like we've done, and we're looking for pairs of 2 that we can bust out. And we're looking for pairs of 2 because we have an index of 2. When you don't see a number on the outside of your radical, you know you have an index of 2 and you need matches of 2 to break out. So we've got negative 2 on the outside. That will, for our answer, we'll have that negative 2 multiplying a 3. This 2 doesn't have a friend, so he stays behind in the radical. Okay, when we factor, do our prime factors for our 45, we're gonna get 3 times 5, right? And that means we can break out a 3, okay, which will multiply a radical with 5 inside because that 5 didn't have a friend, okay? So when those 2 3s on the inside bust out, we'll have 1 3 on the outside. And now we're gonna recombine, we're gonna multiply our negative 2 and our 3 to get negative 6. We'll have that square root 2 and the 3 root 5, and we can't simplify after that because our radicals have a different number on the inside. So here's our answer for example number 2, okay? So let's go ahead and take a look at example number 3 for multiplying radical terms. Example number 3. So example number 3, we've got 2 terms multiplying two terms. And just like we did with our polynomials, okay, we can use the box method. So let's go ahead and take a look at example number 3. Okay, so I'm gonna make a 2 by 2 box because I have 2 terms multiplying 2 terms. My terms go on the outside. Don't forget your signs, very important, okay? We have a positive root 2 and add 2 root 3 here, okay? And when we are doing our multiply step, we'll multiply rows and columns just like we did with polynomials. So root 2 times root 2 are numbers on the outside. Those are just ones, right? So what we'll see for our answer is the square root of 4, right? Because these 2's will multiply the inside terms. Here we've got an outside 2, okay, multiplying an outside invisible 1, so we'll get 2 roots of, and then we'll multiply those inside numbers, root 6, okay? Here we'll have negative root 6 when we multiply the square root 2 and the negative root 3. And then we'll have positive 2 root 3 times negative root 3, which will give us a negative 2 root 9, okay? And just like we did with our polynomials, we want to combine like terms. Okay, we do have root 6 terms that we can combine, but I want to also point out that we've got some perfect squares that we'll simplify. So the square root of 4 is a perfect square, and so is the square root of 9. And as we bring those out of the box, we want to simplify those terms. So the square root of 4 is going to simplify to 2, and if we want to do it like we were doing it, you can see that 4 will factor to 2 times 2. We'll have a pair, and that'll solve to 2. Okay? We have a positive 2 root 6 and a minus 1 root 6, which will give us a positive root 6. Okay? And our last term will simplify to minus 2 times, and then we're going to solve that perfect square root, and that's going to be a 3. So the square root of 9 is 3. Okay? And now we're not done, because we need to simplify this some more. Because that negative 2 times the positive 3 is going to multiply to a negative 6. And now we've got 2 constants, or 2 numbers that we can combine. So 2 minus 6 is going to give us negative 4. And then we've got square root of 6. Now, we can't simplify the square root of 6 because we don't have any matches. So that's why we leave it as the square root of 6. So here's our answer for example 3, multiplying radical terms. And again, we just used the box, but we've got something a little bit unique here where when we're combining like terms, we've got to simplify those perfect squares, okay? All right, that was example number 3. Okay, so for more examples on the Unit 3, go ahead and check for more videos and for our 3D video. All right, thanks guys.